ma'am.
Okay, thank you. So next, Abdul Raheem will be presenting. He is from Ecoseal Development Private Limit, Roosevelt, Australia. His presentation title is Spatial and Temporal Variation in Saline Area in Southern Punjab using different indices through remote sensing data. So kindly carry on. We can see the slide.
Mm, can you see the slides?
Yes.
Thank you. Assalamu alaikum everyone. My name is Abdul Raheem. I am a student of MSc Water Sources Engineering in Center of Excellence in Water Sources Engineering, UAT Lahore. It is a great honor for me to participate in this meeting on the behalf of adopting soil salinity in Southern Indus Basin team, including Dr. Irfan Ahmed Beg, Dean of Mansuam, Dr. J.F. Panthake, and Dr. Saifullah. Topic of my presentation is spatial and temporal variation in saline area in southern Punjab using different indices through remote sensing data. These are the presentation outlines, introduction, problem statement, objectives, study area, methodology, results and discussion, conclusion and recommendation. First of all, introduction. Soil is the backbone of the economy of an agricultural country. Agriculture of any region depends on the soil fertility. Soil salinity is a disease or cancer for a soil. By this disease, annual production of different crops and fruits is reducing day by day. It is usually limited to arid or semi-arid regions. A saline soil is a soil that contains soluble salts in maximum concentrations that affect the growth of the plant. In soil, electrical conductivity is the measure of for salts concentration measurements. The USDA Salinity Laboratory has defined this a saline soil that has an AC of 4 decimol per meter on or greater than that. Soil salinity is causing serious hindrance in the successful agricultural production. Salts decreases the overall water potential of the soil. Therefore, plants expand more energy to uptake and soluble nutrients, which result in overall reduction of plants' biomass. Excessive salts in soil reduce developments of tissues as well as shrinks the soil contents. All these factors result in the reduction of crop yield. Now problem statement, an area of 16 MHA is occupied by the Indus Basin irrigation system of Pakistan. River water of 172 billion cubic meter is distributed by the Indus Basin irrigation system per year. Groundwater levels are rising with Indus Basin irrigation system introduction at the rate of 15 to 75 centimeter per year. The process of evaporation concentrates salts at the top of the consequence, soil and water becomes salinized. More than 30% of the soil groundwater of the Indus Basin is occupied mainly by Punjab and Sindh. Fresh groundwater in quantities of almost 200 BCM has been accumulated in saline groundwater areas in the Indus Basin. In these saline groundwater areas, more than 20 billion cubic meter of fresh groundwater is being recharged annually. Over 2.5 million hectare of irrigated land is affected by severe surface salinity with 3% affecting lands in Punjab, 18% in Sindh, 2% in KPK. The deeply affected areas are 4% in Punjab, 10% in Sindh, and 2% in KPK. According to an estimation, out of 79.61 million hectare geographical area of Pakistan, an area of about 4.5 million hectare is soil affected. In Pakistan, salinity has mainly caused a 20% reduction in crop yield. In the year 2017, waterlogging and salinity in Pakistan have caused severe losses in crop yield and are being afraid to reach 880 million US dollar, while the estimation of total income damage is 300 million US dollar. It is estimated that the land losses due to salinity are 8,000 to 40,000 hectare of land, and because of low crop yield due to high salinity and solidity, there is a loss of about 230 million US dollar of revenue per year. Soil salinity not only affects the soil's fertility but also pollutes groundwater when these salts leach down with irrigation water, and these salts become a part of groundwater. Objectives of my study are to estimate the normalized difference salinity index NDSI for 3 different years using remote sensing approach. Second objective of my presentation is to estimate the normalized difference vegetative index for the different for 3 different using for different 3 years remote sensing approach. Third objective of my presentation is to calculate the area under high salinity and high vegetative indices. This is the study area on which uh, uh, this topic was decided. Study was conducted in part of southern Indus Basin, located in Multan division, consisting of 4 administrative districts: Khanewal, Multan, Khanewal, Bihari, and Odra districts. The area under study is located between river Chenab and Satluj. A network of main irrigation canals, branch canals, and one link canal are located in the area. Average annual temperature
Dear
in
presenter, I
area is
request kindly more explain to your results, please. You will have a limited time.
okay. This is the methodology I have adopted. Basically, satellite data used in this study comes from the Landsat 8 OLI collected over the study area for the February for different 3 years, 2013, 2015, and 2020. Landsat images were collected using raster classes class tool in ArcGIS. These two indices were calculated, NDSI and NDVI. NDSI basically two bands were used, band 4 and band 5. Band 4 red in the range, band 5 in NIR range. These two indices were used to calculate NDSI and NDVIs. Here are the results and discussion. Spatial and temporal variation in NDSI and NDVIs. Normalized difference salinity indices calculated were 0.4 years, 2013, 2016, and 2020. NDVIs were calculated which showed the value 0.08, 0.43, and 0.51 respectively for the year 2013, 16, and 2020. Area under high salinity range was 796 square kilometer in the 2183 square kilometer and 237 square kilometer in the year 2013, 2016, and 2020 respectively. High salinity area increased more than double fold from 2013 to 2016, but showed decreasing trend from year 2016 to 2020. This trend showed that high saline area increased from 2013 to 2016 with 0.14% increment per year, and then decreased from 2016 to 2020 with 1.84% per year. Area under high vegetation was 1603 square kilometer, 184 square kilometer, and 1751 square kilometer in 3 different years respectively. Vegetative area increased from 2013 to 2016 by 0.24% per annum, but decreased from 2016 to 2020 by 0.22% per annum, which is not a significant change. Conclusion and recommendations. High saline to moderately saline area is present more in Multan districts as compared to other administrative districts, which is causing less agricultural yield production in the area. Moreover, vegetative index in the area is also increasing with every passing year, which reflects the importance of agriculture in the area. is increasing to be explored in terms of efficient research and adopt management strategies on policy making, planning, and farmer level so as to meet effectively with this fatal challenge. Cropping pattern and agro management practices need to be reconsidered in order to minimize the effect of salinity for the enhancement of agricultural benefits. Very much.
Okay, thank you very much. For